Hello again. Welcome back. This is part 9 of chapter 13. And in this one, we're going to continue our colligative property discussions. But just like we did melting point depression, now we're going to do boiling point elevation. So we can add things that are going to cause the boiling point to be higher. So you have to get to a higher temperature in order to boil. And it's very similar to what we saw with the freezing point depression. The boiling point of the solution minus the boiling point of the solvent is the depression of that temperature, and the mole concentration times the boiling point elevation constant is going to give you that in degrees C per mole. So very, very similar to the freezing point depression. So what mass of ethylene glycol in grams must you add to 1 kilogram of water to produce a solution that boils at 105 degrees C? Since pure water boils at 100 degrees C, the change in boiling point is 5. So 105 minus 100 is 5. So first of all, we look and we see that we have we can get the mole concentration, right? So we're going to, if this is our original formula, then we can rearrange that to be delta T B divided by K sub B. And that's going to give us our mole concentration because the depression is 5 degrees C divided by the where is it? Oh, I'm going to have to look it up. That's right. KB is 0.512 degrees C per mole. So that's going to be 0.512 degrees C per mole. And since you're dividing on the bottom, it goes to the top, and that gives us 9.8 mole concentration of ethylene glycol in water. And it wants to know what the mass of the ethylene glycol is going to be. So we know that we have 1 kilogram of water and we have 9.8 moles of the ethylene glycol per kilogram of water. Okay, because that's what mole means. And then if we multiply that by the formula weight of ethylene glycol, which is 62.1 grams per mole, and we're going to get rid of kilograms of water, moles of ethylene glycol. We're left with grams of C2H6O2, which is what we're looking for. And so we do our calculation, and we are going to get 610 grams of C2H6O2. So we were just basically, remember, you got to know how to find moles, and then we've been doing that for quite some time, and then you should be able to rearrange that formula to look for anything that is in that formula if you're given the other two things. So that's boiling point elevation. Okay, now this one we were just looking at. We were using the formula to actually find how many grams it would take to do that. So, and then the boiling point. This is one that is more traditional, and it's going to work just like the depression that we did before with freezing point, in that you're going to have the delta TF, and that's going to be the M times K sub F, right? And then once you get that, you're going to use the you're going to take that boiling point difference and put it in here and subtract it. Sorry, hang on a second. I want to make sure I'm looking at the right one. Where is it? There it is. Okay, yeah. So it's KB, sorry, because I'm looking at boiling point. You're going to get that, and then you're going to subtract it from the boiling point of water. Or actually, you're going to add it this time because it's an elevation. So you should be able to do that one without any problem. And that is boiling point elevation.